Okay. So, for your grain size analysis, meron tayong dalawang methods, which are your sieve analysis and your hydrometer. Yan, yung hydrometer natin. Saan ba siya? Hydrometer. Pero yung di-discuss ko lang is your sieve analysis. Okay, so simple lang naman yung sieve analysis natin. Okay, so meron tayong stack of sieves. Yan. Meron tayong sieve shaker. Pero yung sieve shaker, pwede rin naman na manually ma-shake. Pwede rin tayong mag-shake. Okay, basta yung um, principle lang naman ng sieve analysis is from the top, yan, meron tayong sieve na may pinakamalaking opening, okay? So, sa unified classification system natin, we are considering na yung pinaka-topmost na sieve is 3-inch opening. 3-inch yung opening, okay? And then, sunod is your number 4 sieve, which has your 4.75 millimeters. Yan, 4.75 millimeters na opening. And then, lastly is your number 200 sieve, which has your 0.075 millimeters opening. Yan, okay? Okay. Yan, so, according to our unified classification system, yan, lahat ng mag-pass through sa 3-inch opening na sieve is considered gravel. Okay? Pero may limit yon, okay? Dapat hindi na mag-pass through sa number 4 sieve para ma-consider siyang gravel. So, the soil which are passing through 3-inch sieve and retained at the number 4 sieve is considered gravel. Lahat naman ng mag-pass through sa number 4 sieve and is retained at number 200 sieve is considered as sand. And lastly, lahat na nang mag-pass through sa ating number 200 sieve is considered fine. Okay? Yan. Okay? So, ganito yung mga sieve natin. Okay? So, pagdating ng araw, kapag face-to-face na, pwede nyo na silang gamitin. Okay? Nasa laboratory lang natin sila. Okay? Yan. So, ito yan. Okay? So, sieve designation. Yung, sabi ko kanina, yung 3-inch sieve, yan, or the sieve larger than number 4 sieve is the 3-inch sieve. Yan. So, lahat ng mag-pass through dito is considered gravel. Okay? Considered gravel. Pero, dapat hindi na siya mag-pass through sa number 4 sieve. Yung susunod natin. So, that is the 3-inch sieve. And then, sunod is your, nasaan na siya? Number 4. Sunod sana yung number 4. And then, number 10. Yan. Okay. Yan. Basta yan. Okay? So, lahat ng mag-pass through sa 3-inch sieve, then ma-retain sa number 4 sieve is considered gravel. And then, lahat naman ng mag-pass through sa number 4 sieve, and then mag-retain sa number 200 sieve is considered fine. Wait lang. Baka nagkamali ako. Sand pala is considered sand. And then, lahat ng mag-pass through, yan, sa number 200 pababa, are fines. Yan, okay. So, ito yan. Okay, so, this is the sieving procedure. So, first one, yan, kailangan yung write down yung weight. Yan, write down the weight of each sieve as well as the bottom pan to be used in the analysis. Bakit ba? Okay? So, kailangan yung i-record yung weight ng mga sieves without the sand, of course. Para pag tapos na yung sieve analysis natin, pag winayon na yung mga sieve with the retained soil, i-minus nyo na lang yung weight ng sieve para makuha nyo yung actual na weight ng ating soil. Yan. Okay, then second, record the weight of the given dry sample. Yan. Yung buong soil natin, kailangan dried po yan. Okay? Hindi po advisable na basa yung soil natin kasi kakapit yung soil particles natin sa sieve natin kapag basa. Okay? So, kailangan dry. Okay? So, kailangan nyo rin siyang i-weigh. Then, i-record nyo yung total weight ng ating dry sample. Okay? Then, next one is Make sure that all sheaves are clean, yan. Given naman yan. And assemble them in the ascending order of the sheave numbers. So number 4 sheave at the top and 200 sheave at bottom. Okay? Kasi mostly, di ko na sinabi yung 3 inch dito kasi wala tayong 3 inch. Yan. Baka maghanap kayo. Okay? Pero alam niyo naman na siguro ma-estimate yung sizes ng 3 inch na bato. Okay? So, estimate nyo na lang. Huwag na kayong maglagay ng mas malaki pa sa 3 inch na bato. Okay? So, number 4 sheave at top and then 200 sheave, number 200 sheave at bottom. Place the pan below number 200 sheave. Okay? So, pag sinabing number 4 sheave at top, so number 4 sheave ito sa taas. Baba ko lang. Number 4 sheave ito and then number 200 sheave yung nasa baba. So, itong mga nasa gitna naman, dapat in ascending order yan. So, kapag ito, so number 4 ito, dapat to next siguro number 10, 20, ganun. Okay? Yan. Okay? Basta yung importante lang naman dyan is yung different, dapat yung sheave dito. Okay? Dapat different yan. Then place the sheave stock. Yan. Place the sheave stock in the mechanical shaker and shake for 10 minutes. Okay? Pwede rin naman na manual kung wala kayong sheave shaker. Kayo na lang yung mag-shake. Okay? Pero mahirap lang kasi yan. 10 minutes diretso. Okay? Then remove the stock from the shaker and carefully weigh and record the weight of each sheave with its retained soil. So, kada isa dyan, merong mare-retain na soil. Siyempre, merong hindi magpapastro dito. So, dito na siya, mare-retain na siya dito. And then, magpapastro yung iba dyan. Meron ding mare-retain dito. Magpapastro yung iba dyan. Mare-retain siya dito. And then, etc. Hanggang yung panghuli, meron na lang dust dito. Okay? So, considered pa rin na soil yon kahit dust na siya. Okay? So, kailangan nyo siyang i-weigh. Dapat yung balance nyo, dapat hindi siya yung 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 kilos lang. Dapat nasa ano siya, milligrams or lesser than milligrams, micro. Yan, okay? Para makuha nyo yung exact na weight ng ating soil specimens. Yan. So, kailangan nyo siyang i-weight. Okay, nasa handouts nyo na yan. Okay, then your data analysis after sieving, yan. Kapag na-weigh nyo na-record nyo na lahat ng retained soils sa ating sieve. Okay, so number 1, so obtain the mass of the soil retained on each sieve by subtracting the weight of the empty sieve from the mass of the sieve plus retained soil. Yan, gaya nga nung sinabi ko kanina, yun yung purpose kung bakit natin winay yung ating empty sieves. Yan. So, mass of the sieve plus retained soil. And record this mass as the weight retained on the data sheet. The sum of these retained masses should be approximately equal to the initial mass of the soil sample. Yan. A loss of more than 2% is unsatisfactory. Yan. Okay. Yan. So, hindi natin maiiwasan na iba na yung total weight pagdating sa last data natin. Okay? So, meron din naman tayong yung error factor. So, kailangan na yung loss natin is not more than 2%. Yan. So, for example, I have a total soil sample na 500 kilograms. Then merong na-retain sa lahat ng sieves. Okay? And then, kapag pinag-sum ko yung mga na-retain masses sa sieves, hindi ko na ma-attain yung 500. Let's say, that is 495. I think that is acceptable pa naman. Okay? Yan. So, acceptable pa naman yun. So, next one. So, calculate the percent retained on each sieve by dividing the weight retained on each sieve by the original sample mass. So, papakita ko mamaya yung sample computation natin. Okay? And then number 3, calculate the percent passing or percent finer by starting with 100% and subtracting the percent retained on each sieve as cumulative procedure. Okay? So, ito pa yung mga sieve sizes natin, US standard sieve sizes. Yan. For sheave number 4, that is 4.75 millimeter opening. For sheave number 5, 4. Yan. And so on. So number 200 sheave has a 0.075 millimeters opening. Ito po yung standard na ginagamit natin. Okay? Ito yan. Okay. Ito naman, hindi natin ginagamit to. Pero linagay ko na lang for your reference. Okay. Ito na lang di-discuss. Oh, wait lang. Yan. Okay. So, ganito yan. So, yung number 1 sheave, yan. So, may retain na soil dyan. Yung magpapass through dyan, lahat nasa baba, nagpass through sa M1. And then, meron ding na-retain sa M2. So, lahat ng nasa baba na naman, dito, nagpass through kay M2. Dito. Kay sheave number 2. And then, so on. Yan. So, the mass retain on each sheave, yan. Sample lang to. Okay? Yan. So, M1, M2, and so on. Okay? Next tayo. Okay. So, this is an example of your sheave analysis. Yan. So, example result. So, ito yung mga ginamit na sheave numbers. So, number 4, then sunod is 10, 20, 40, 60, 140. Then, sa pinakamababa is 200 sheave, number 200 sheave. And, of course, your pan. Okay? Yan. Ito yung mga diameters. So, 4 is 4.75 and so on. And then, kay 200 sheave is 0.075 millimeters. Okay. So, after yung sheave analysis natin or sheaving natin, so makukuha natin yung ating mga masses sa different na sheave natin. So from the start of our sheave analysis, yung una natin ginawa is to weigh yung empty na sheave natin. So ito yung mga nakuha nila, so 116 hanggang sa number 200. Yan. So 90.92. So listed na dito yung mass ng ating empty sheave. Yan. So, kailangan kasi yan. And then, next one is the total mass of your mass of the sheave and the soil retain. So, after yung sheaving natin, yung mga sheave natin with the retained soil, i-weigh natin siya. So, dito kasama yung mass ng empty sheave. Okay? Yan. So, ito yung nailist siya. And then, after yan, after nyong ma-record to, and then, you need to solve the soil retain. So, kailangan nyo nang isubtract yung weight ng ating empty sheave sa total mass ng sheave and soil. Yan. So, 166.13 minus 116.23. So, we are left with your soil retain as 49.9 grams. Okay. Yan. And so on. Hanggang sa 10.2. And of course, tandaan nyo, meron pa ring soil na matitira sa pan natin. Okay, so 301.19 yan. So yung soil retain dyan is 231.0. So kung titingnan nyo, marami siyang fines. Pagkakita nyo pa lang dito, marami na siyang fines. Kasi nag-pass through sila sa pinakamaliit na sheave, which is 200, yan. 231. So dominant yung fine dito. Okay? And then of course, gaya nga sinabi ng procedure kanina, yung sa data, kailangan yung kunin yung percent retain. Okay? Yung gagawin nyo lang dyan is, kunin nyo yung soil retain and then i-percentage nyo siya with respect to the total weight. So 49.9, yan, ilang percent siya sa 523.7. Alam nyo na mag-compute using your calculators. We will have your percent retain as 9.5. Yan. And so on. Yan. So, 36.5 to 523.7. And hanggang dito, 231.0 to 523.7. So, 44.1. And then lastly is to compute kasi need dito yung percent passing or percent finer. Yan. Percent passing natin, parehas sila ng term ng percent finer. Medyo naglalag yung laptop. Yan. So, percent finer. Pero ang terms yan. Okay? Bakit ba sinabing percent finer? Okay? Bakit ba sinabing percent finer? Yan. Percent finer than the percent finer than the retained soil at the number 4 sheaf. Yan. Ilan ba yung percent finer than the percent retained at the number 4 sheaf? Siyempre, 100% nung una, lahat ng nag-pass through kay number 4 sheaf is 90.5. Okay? Yun. Okay? 90.5 ng total weight. Pero para di na kayo maguluhan, okay? Gamitin nyo na yung data ng percent retained. Okay? Ganito lang yan. Okay? So, 100, yan. Siyempre, 100% tayo mag-umpisa. Minus the percent retained, we will have 90.5. And then, after that, you will use this one, 90.5 minus 7.0. We will have 83.5. The next one, 83.5 minus 8.0, 75.5. Then, 67.8, 67.8 for 4.4, then 63.4, and so on. Hanggang mag-0 dapat yan. Okay? Yan. Pag hindi nag-0 yan, pag hindi nag-0 yan, meaning, mali yung ginagawa nyo. Okay? Maling-mali. Okay? And of course, yan, tingnan nyo rin. Okay? Tingnan nyo rin kung tama ba yung total. Okay? Let's say, na-compute mo na ng 100 grams yung linagay mo sa pinakataas na sheaf. Okay? And then, nakuha mo na yung soil retained. Tapos, pag sinam mo to, 90, let's say 95 grams na lang yung natira. And that is 5% loss. So, yung test na yon is null or hindi siya considered. Mali. Okay? Marami masyadong error. So, kailangan, if may loss man, dapat if 100 grams yung total, dapat yung total weight na makuha nyo dito is from 98 to 100. Yan. Okay? Para ma-consider siya. Okay. Okay, so may example computation tayo dito. So, yan. So, for example, we have a soil, a soil mass with a total mass of 500 grams. And then, we have a retained mass on the number 4 sheaf with 9.7 grams. Yan. So, kukunin mo yung mass retained and the percent finer. Yan, okay? So, for the number 4 sheaf, kukunin natin yung mass retained. Yan. So, quantity passing, that is total mass minus mass retained. Okay? So, 500 minus 9.7, that is 490.3 grams. Yun yung nag-pass through sa number 4 sheaf, 490.3 grams. Okay? And then, lastly, we need to compute the percent finer. Okay? Ito. Okay? So, the percent retained is calculated as, yan. So, percent retained muna. So, 9.7, syempre, 9.7 yung nag-retain. So, 9.7 all over 500. That would be 1.9%. Yan. And then, yung nag-pass naman kay number 4 sheaf, so, kabaliktaran, gagamitin yung 490.3. Yan. So, that is 490.3 all over 500 times 100. Or, you can use this one, 100 minus 1.9. As long as number 4 sheaf talaga yung topmost na sheaf nyo. Okay? If not, hindi nyo pwedeng gamitin yung 100. Okay? Yan. Okay? And then after getting all your datas, yung kailangan yung gawin na susunod is to plot your particle size distribution graph or curve. Yan. Okay? With your semi-logarithmic paper. When I say semi-logarithmic paper, yung isang axis is on the linear scale, yan, and yung isang axis is on the logarithmic scale. Semi-logarithmic scale. Yan. Okay? So ito, on the linear scale, you need to input your percent finer. Yan. So 0, 20, 40, 60, 80. Depende sa gusto mo. Basta linear scale. Okay? And then at the logarithmic na axis, yan, you need to input the particle size or the diameter of your shapes. Okay? Yan. Pwedeng pabaliktad. Pwedeng from 100 to 0.001 or pwede rin to from 0.001 to the largest particle size na nakuha niya. Okay? Yan. So, at the logarithmic scale, yung axis natin, hindi tayo mag-uumpisa sa 0. Okay? Mag-uumpisa tayo by tens. Okay? When I say by tens, yan. So, if I started with 1, let's say 1, and then this should be 10. And then 10 times 10 again, this should be 100. And then 100 times 10, this should be 1,000. 100 times 1,000 times 10, this should be 10,000. And so on. So dito nag-umpisa tayo sa 0.001 and then times 10 lang natin siya, that it would be 0.001. Then times 10, 0.001. Okay? If nagugulan kayo, yan, okay? This would be 0.01, then this would be 0.002. This would be 0.00, hindi nyo makita. This one, yan. This would be 0.002. This one, 0.002. 3, 0.004, 0.005, and then so on hanggang mag 0.001. Okay? And then so on. Yan. So, dito naman, baka di nyo talaga maintindihan. This would be 10, then 20, 30, 40, 50, 60, 70, 80, 90, then 100. Dito naman, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, yung scale niyan is by tens. Okay? Yan. Okay. So, yun yung particle size distribution natin. So, next one, isa pa sa kailangan natin na i-discuss is your Atterberg limit. So, I will discuss it at the next video.